Hello, we're going to pick up 10.6 here, finishing up chapter 10. We looked at the binomial distribution. I just want to talk about what a distribution is. So here's an example of one. And this is a look at the sum of rolling two dice. Of course, the most unlikely or the lowest probability is 12 and 2. Because the only possible way to roll those is to get a 6 and a 6 or a 1 and a 1. There's no other combination. Highest probability is a 7 because a 7 has multiple ways to add up to 7. You can have a 6 and a 1, you can have a 5 and a 2, and so on. And so this is kind of what we're looking at, but some of the probabilities we will study will not be symmetrical like this. So perhaps maybe you've got a unfair die where it's weighted to get 6 more often. Okay, so then maybe this is even lower than originally had started, and it's skewed. We call this skew. Maybe towards the direction of the highest piece. Now, it doesn't necessarily mean that the 12 is going to be the most likely because, again, it's still, you can only get it with a 6 and a 6, but the idea is that it is skewed to the right, perhaps a weighted dice or something like that. So if the probabilities are different, then you can have distributions that don't always match up, and we can kind of calculate each of those individually. That's kind of what I've asked you, and we took notes on this on, I guess it was Friday. But the idea is that here I've asked to kind of calculate a probability of a specific thing. So remember, n is the total number. K is going to stand for success. And so there's K again right here. And then P is probability of a success. And then here is failure, because you have to have the failures just as much as you have successes. And then finally, this part is the number of failures. So just to kind of get back into it, a reminder here, you're going to roll a die 15 times. What's the probability to roll a 2 exactly 4 times? Well, the probability of rolling a 2 is 1 out of 6, which means failure is 5 out of 6. Okay, so those are things you can calculate right away. There's 15 rolls. You are going to choose 4 of them to be successes. So probability of a success is 1 out of 6. We need that to happen 4 times. The probability of failure is 5 out of 6. We need that to happen 11 times. Because the idea is it says you roll a 2 exactly 4 times. So you can't roll it 4 and then, oh, we're done. You need then 11 failures. And so that's part of the probability as well. Even though it's more likely to happen that you fail, we need to have that probability. Now, I want to show you another way that we can calculate this on our calculators. If you have a graphing calculator, get it out. If you don't, find one or take some notes on this. Pause if necessary. All right, there's a distributions button. You have to push the second, and then you are going to go into the VARS button, which is second so get you into distribution, and then you are going to have to go scroll down, and it's there's 2 of them that we will use today. The specific the one I want to look at is A. It's Binom PDF. A Binom PDF. And so once you scroll down to A, hit enter on that one. There are a couple of things that we have to enter, because it just kind of comes up like this, and so there's really not it doesn't ask you for anything. We need to enter them, and so here's kind of the setup. First, you're going to enter the number of trials. So the calculator has to know how many times are you going to roll the die. Then you are going to enter the probability of success, and then you're going to enter the number of successes. And that's really everything the calculator needs to kind of figure out the probability of that event. So for our situation up above, and make sure you write this down, it's very important, you will use this a lot. You probably won't use this formula up here very much anymore. The number of trials is 15, so we're going to say into our calculator, 15, comma, probability of success is 1 over 6. Put it in parentheses just to be sure, and the number of successes is 4. The comma, again, is right above the 7. You'll need to separate each of these with a comma. But once you have that entered in, you can see that the probability is fairly easy to use. So number of trials, probability of success, and then the number of successes. But there's another handy thing in the calculator, and we're going to go to a different example to investigate the real power. I mean, this is not that much quicker. Using this formula isn't that much harder. I would say when we're dealing with an exact amount like this, you can choose whichever method you want. You know, this one obviously we generated on Friday. This one not as much to enter, but then again, it's a little bit more kind of mystical how the calculator does that. Let's take a look at an example where the calculator will undoubtedly be better. We're going to go back to the multiple choice question. I think we looked at one of these on Friday. Each question has 4 choices, so obviously there's only one. The probability of success is 1/4. Only one right answer. So the probability of success is 1/4. And this one asks us, what is the probability you get an A, as in 9 or more? So we basically are looking for the probability of 9 right or 10 right, okay, which you know, of course, or is addition. And so we need to find the probability of getting 9 right. So 10 choose 9. And then we need to find the probability of 10 choose 10. And so this won't be too difficult to do. Just two combinations that we would need to solve. So it's going to be 10 choose 9 times 1/4 to the 9th, and then we need to only get one wrong, which is 3/4 to the first, and then it's 10 choose 10 times 1/4 to the 10th, and this 3/4 will be 0 here. And that's not too bad, but unfortunately, if you look at the next question, and we can come back and calculate this, look at the next question, what is the probability you fail? You get 6 or less. So now we need the probability of getting 0 right, 1 right, 2, 3, 4, 5, 6. And this is the type of question that we do not want to have to solve by hand. So we can go back into our distribution, second VAERS, and if you go down to now again, scroll down past binomial PDF or binom PDF and scroll to binom CDF. The P and the D are the only difference here, and that difference is going to stand for which probabilities you're adding together. So now for binom CDF, you're going to enter 3 things, and it is going to be similar. You're going to enter the number of trials, the probability of success, but then the last part is not going to be how many you exactly want to get right, is what you want to sum up to. So let me write that all out here on this line. Okay, you've got the number of trials, that's the first thing. and that isn't going to be any different from the PDF. Number of success is also the same, not any different than PDF. But here is the difference. What do you want to sum up to? So for example, the one that we are looking at here, we want to sum up to 6. So we're going to enter binom cumulative distribution frequency. We have 10 questions. The probability of getting a question right is 1 out of 4. We want to sum up to 6. And so what you are telling the calculator to do is not just sum exactly 6, but from 0 up until 6. All right, and so you can only sum up to, not down to. So think about that when we're doing this problem up here. Well, Mr. Sire, why didn't you show us that for, why didn't we put 9 in? Okay, it doesn't sum down to, it sums up to. Okay, up to. So we could figure that out using using that method, but I think that this one, we were fine doing these two. Here, without a doubt, we need to sum up to. So now if you type this into your calculator, just as you see it here, and again, you can do 0.25, 1/4, it doesn't matter. Calculator knows. This probability ends up being 0.996494. Obviously very close to 1. We expect that if you don't study, you will probably fail. You'll not be able to guess 7, 8, or 9, 10 questions right. All right, so CDF is sums up to, and sums up to.